So we've used third-party images and we've pulled them down and we've created containers from them. And we've built our own images on our machine. But it's no good just on our machine. We need to share it with other people, or we need to actually deploy it somewhere so it can be running in Kubernetes or any other platform that runs containers. Now, you may remember this diagram from earlier on in the course where I explained about pushing an image to an image registry or container registry, and someone else, in this example Jane, can pull an image down and create the container from it. The same pattern applies if you're hosting it somewhere. So we'll change Bob to be your CI/CD system, so that could be Azure DevOps, GitHub Actions, Jenkins, whatever. And imagine when you push your code in source control, then your CI/CD system picks it up and does your Docker build and pushes to an image registry. And then let's change Jane, and Jane can be a Kubernetes cluster. So Kubernetes would also be doing a pull. So exactly the same pattern. Your CI/CD system would not be pushing the image to Kubernetes. It would still be pushing it to the container registry. Kubernetes would then pull down the image and create a container from it, just like the example before where it was Jane doing a pull and doing a Docker run. It's the same pattern. So if we go back to Docker Hub now, you can see that I've created an account called Dome Train Course. So I'm going to create two repositories, one for the API and one for the front end. So if we click on this and just type API, and you'll notice that we've got public and private as an option. I'm using a free account, so you can see here in red it says I'm using 0 of 1 private repositories. So do bear this in mind. If it's public, anyone can pull that image down and create a container from it. So be careful from a security point of view. For this, it doesn't matter. If it's your company's web app, you probably don't want to be making it public. The private ones, you get more of them with a paid for Docker Hub account, or you can use something else like Azure Container Registry, AWS will have one, Google will have one. You can host your own container registry. So there's lots of options which I spoke about earlier in this course. But for now, I'm just going to make them public. So this is creating my API. If I go back up to repositories again and then create another one, we will create the front end. And exactly the same applies here. I'll make it public. So you may notice that this image has a prefix, Dome Train Docker Course, which is my account's username. But Nginx didn't have one. RabbitMQ didn't have a prefix. So if we actually search for Nginx now, we can see that this has got a tag, Docker official image. So that's the reason. And if I jump over to this page now, this basically describes it. I'm not going to go into this because this is out of context of this talk, but I just wanted to explain why things like Nginx, Ubuntu, RabbitMQ don't need the username prefix. It's because they've gone through a rigorous process to become an official Docker image. So if we go back to the command line now and do Docker push, so this is obviously we've got the pull and now we're doing a push. And if I do API, then this is going to fail for a couple of reasons. First of all, so it says access denied. First of all, I could be anyone. I haven't logged into my Docker account. So even though anyone can pull because it's public, it's a bit of a security issue if other people can push to it. So to log in, we've got a Docker login command. If I do -help, then we can see we can specify a username and password, -u, -p, or if we don't, it'll ask for it. So if I enter the credentials of the Dome Train Docker Course account, then we are now logged in. So now if I do Docker push API again, it's going to fail for another reason. And that reason is I have not put that prefix in because my API isn't an official Docker image. So I need my username prefix. So if we build our image again, jump over to the API, do Docker build -f. For the API, we had to specify the Docker file because it's in a different directory of the context. Give it a tag name. So rather than API, which is what I would have done before, if we jump over and head over to the repository and copy this, pop that in there, we'll get rid of the tag name and we'll just use latest for now for this demo. And then we want dot for the Docker context. And that's built. So if we do Docker push now and specify this tag name, get rid of the context, then this will now work and is pushing them up. And notice how this is actually showing each different layer, the cache layer. So it's in the same way as a pull will cache layers, a push will as well. And if we go back to Docker Hub and refresh the page, we can see we've got our new image with tag latest. Going back to the command line, if I go back to the directory with Docker Compose now, then we've also got a Docker Compose build command. Now remember, a lot of the Docker Compose commands were very similar to the Docker commands like Docker Compose PS, Docker Compose logs, Docker Compose build. So if I run this now, then that's built it. Again, it's cached, so that's why it's quite quick. If I do Docker Compose push, then this won't work initially because we've got to go to the code and add that prefix. Remember the Docker Compose YAML file? So let's add that and then build again. And then we can do Docker Compose push. And that's pushed our images. And note that the API, it says layer already exists because we've already pushed it. We pushed it without Docker Compose. We did an explicit Docker push image name. But typically, because I tend to have a CI/CD pipeline per service, I don't really use Docker Compose for pushes or builds. I would just do Docker build that explicit service and push that individually. So even though you can use Docker Compose, I never really do it. And we'll talk more about using Docker in CI/CD a bit later on in this course. But that's it. It's that simple to, once you build your image, to push it to a container registry and other people can pull it down, or your hosting provider like Kubernetes, whatever it is, can pull that down and create a container from it. We've covered quite a lot of Docker goodness now, but we still have more to cover. However, we're going to take a little break now from learning new Docker stuff and look at different ways we can put our newfound Docker knowledge to good use. For example, using it to run our tests as part of our build, including testing with a real database, also building our images and running those tests in a CI/CD system. As part of a developer's daily workflow, we change code, we push it to source control, and typically we're not doing the build locally and deploying it to some server, unless we go back like 20 years in time. Typically, a CI/CD system would notice the changes in Git and trigger a pipeline and do the build and deploy it somewhere. So that's what we're going to do now in this section. If you go to docs.docker.com and go to manuals, then scroll down to Docker build, there is a section called continuous integration. That's CI. The CI with Docker bit is just talking about continuous integration. There's also a GitHub Actions section. Now, it's a shame they don't cover more CI/CD systems like Jenkins, Azure DevOps, you've got TeamCity. There's quite a few different options, but this is showing GitHub Actions. There's a few different sections here like secrets and managing tags and labels and things. We're just going to go to the introduction section, scroll down to the bottom and pinch that final example here. So if you download the code that's in this section, the zip file, then you'll see that we've got a GitHub folder and there's two GitHub Actions in this folder. One for the API and one for the front end. Now, these are largely the same as what we saw in the documentation with just a few small changes. So the first one is I've added a path here so that this action will be triggered when I make changes in the API, when I push it to Git. And the front end one has a similar one for the front end. Another change is I've added this line here. So it's an extra tag. So as well as doing latest, which is what the documentation has, I'm also using a new tag, which is the GitHub run number. So that'll add two tags. And then lastly, I've just updated the context and the file for the Docker file just to match our file system layout. So if we go over to GitHub Actions now, so I've temporarily for this demo just pushed the code to my own GitHub account. If you want to follow along, just take the zip file and upload it to your own GitHub account. And if we go to the Actions section at the top, then we can see where I've run this before. If I go to build API, then look at one of the previous ones, the logs. Then we can see we've got all these settings like build and push. This will all look very familiar. All the Docker file commands like work directory, we've got run, .NET build, all this kind of stuff. Basically what you saw on the command line. And then if we jump over to Docker Hub, then we can see that that's been pushed. So we've got latest and we've got a numeric tag value, which is the GitHub run number. One thing you will notice here is that, and you'll see this sometimes in Docker, you'll see the term build X. So this is just the new version of the build tooling, and it's actually the default. So if you've installed Docker Desktop, if you go to the command line and type Docker build and then enter with no arguments, we can see in the help, it's actually an alias for Docker build X build. So I just wanted to point that out. If you see Docker build X, that's just the newer build system that uses something called build kit for building the images. So now we've got that running in our CI/CD, the next section, we're going to have a look at running tests within our Docker build, and we'll also get that working as part of this same GitHub Action workflow.